Today we're going to be looking at the partial products algorithm, and that is this. So if we have 56 times 9, the way it works is like this. So we look at it, instead of 56 times 9, we say, well, I know I have 9 50s. So I'm going to put that here, 9 50s. Alright, and then I can use what I know about multiplication to set it up. And I'm going to set it up so that it's directly under here to be a little bit more, to be a little easier. 9 50s, 9 times 5 is 45, and then I add the 0. Okay, so 9 times 5 is 45, I add the 0. And then I still have to do 9 6s. Okay, so 9 6s is going to be just like 9 times 6, and that's going to be 54. And then essentially what I do is I just add it together. So I have 0 plus 4 is 4, 5 plus 5 is 10, put down the 0, carry the 1, and then 4 plus 1 is 5. So the answer would be 504. And the reason this is called a partial products algorithm is because we can do this with any multiplication problem that works this way, that looks this way. Okay, and if I were to do it with a traditional algorithm, we would still get the same answer as I do with the partial products algorithm. So just to show you, if I did 56 times 9, I could do 9 times 6 is 54, put down the 4, carry the 5. 9 times 5 is 45, plus 5 is 504. So if you do the traditional algorithm, you'll see it produces the exact same answer as the partial products algorithm. I'll do one more example just to help everybody see the idea of the partial products algorithm. And it looks like this. So let's do 83 times 7. And we'll set it up like this. So I know I'm going to do 7 80s. Okay, so I'm going to do 7 80s, and that's like 7 times 80. Okay, and 7 80s is going to be 7 times 8 is 56, and then 1 0, so that's 560. And then I need 7 3s. And I need 7 3s. So I'll put it right here, 3s. And 7 times 3 is going to be 21. And I will add those together, and I'll have 0 plus 1 is 1, 6 plus 2 is 8, and then bring the 5 down, should be 581. And just to show you how this compares with the traditional algorithm, if I do 83 times 7, traditionally, 3 times 7 is 21, down the 1, carry the 2, 7 times 8 is 56, plus 2 is 58, 581. So you still get the same answers, but this is another way of thinking about it than the traditional algorithm. It's called the partial products algorithm. And as far as how you can help support kids at home with this, please have them keep practicing their multiplication facts and multiplication practice problems that will use any of these algorithms. Whichever way they can relate to best is how they should practice. There are a number of different algorithms which will work every time as long as they're doing the multiplication correctly and following all the correct steps. So we want also kids in this unit to be able to use arrays to model multiplication. We've been working on that, setting up arrays. We've used the GeoBoard some, and to apply the zero property of multiplication to finding partial products. So just knowing, for example, that when you do 9 times 50, it's like doing 9 times 5 and then adding a 0 on the end. So it's like extending those facts that we've been working on. So this is lesson 9.4, a multiplication algorithm for grade 3 everyday math.